What is up, ladies and gentlemen? This is Dirk Hamel-Wood, and in this video I'll be covering Chapter 11, the Environment, Section 1, Data Logging. What is data logging? Data logging is the use of computers to automatically record data from sensors without human supervision over a long period of time. Applications of data logging. It is used to collect weather data, which can be used later for weather predictions. It's also useful for monitoring volcanic and seismic activity. Robots like the Mars Pathfinder use data logging to report back information about the Martian atmosphere. One of the more practical applications is in nuclear power stations. Data logging is used to monitor reactor states and report back any abnormalities which may lead to complications, so that way the supervisor doesn't have to be constantly monitoring. The system does that for them, so that way they can respond in kind if there's any kind of emergency. This is an example of a simple humidity sensor, which might be used to measure humidity in a local area, just kind of a standard thing. Hospital intensive care units can also be used to record and monitor patients' vital signs. These systems sound a warning. If sensors register a value outside the given parameters, it will sound a warning to signal help. For example, the heartbeat monitors, if they see the heartbeat go dead, then they will signal an alert, and all the doctors come running. All commercial aircraft are fitted with flight data recorders, which log data about the operation of the aircraft, such as speed, altitude, heading. During crash investigations, the FDRs is also used as a source of information to pin responsibility on whomever was responsible. This also records. It didn't say that in the book, but it also records conversations that are actually going on in the cockpit. Just kind of a fun fact, I guess. This is an example of before and after the flight recorder unit. As you can see in the right picture, that is after a crash, but even as mangled as it is, the data was still able to be retrieved, so it's a very practical application of data logging. Traffic pollution levels are able to be monitored via roadside sensors, which log levels of gases in the atmosphere, and for some models, the number of cars passing by. This helps assess the need for and the effect of traffic reduction techniques, which is really important in big metropolitan areas. Race cars additionally use data logging as part of their telemetry systems, sending data back to the pit team every lap, including fuel remaining, tire temperature, tire pressure, height from the ground, and engine RPM, which help to prevent really dangerous or fatal car crashes, as well as provide advantage in the race. Advantages of data logging. Data logging has many advantages over manual data collection. For example, the ability to sample large numbers of variables at once, extremely frequently, and over a long period of time, and even years or more, which may be measuring temperature every hour for a year, would be really impractical and a huge waste of time for a human observer. But sensors can pick this data up automatically, and it wouldn't be a big deal. Data integrity is better. Excuse me. Data integrity is better because computers can sample data at more precise intervals, and because they don't suffer from human error. Additionally, they can output this data in an easily readable format, such as a graph, fairly effortlessly. Data logging is much more safe than traditional data collection. This is because data logging instruments can survive in harsh areas, such as places with extreme temperatures or areas filled with poisonous gas. Sensors are commonly used to monitor volcanoes, as well as biomes that are really difficult to observe in, such as deserts. Finally, since data logging processes are automated, they are useful for systems that only require attention when abnormal situations arise, such as nuclear power plants and medical monitoring. This means the operators simply need to be alert in case of emergency, not constantly monitoring. Now, this is an example of a system of sensors that are used to detect seismic activity and volcanic eruptions and similar events. This is kind of a free-form flowchart that I found online, so not really exact. The data logging process. The process is fairly straightforward. Analog data is collected using a variety of sensors. Then it is converted to digital data by an analog to digital converter, which was actually covered in one of my previous videos. The digital data is analyzed and processed. Alarms or alerts can be sounded if data is outside predetermined ranges, such as the reactor states in nuclear power plants or certain physical thresholds within the human body in medical monitoring systems. Outputs such as graphs or tables are produced, and that's the fun stuff. These are my references, and thank you for watching.